Okay, so before we jump into day two, guys, you guys had just these two problems on day one, practice multiple choice. We see we cross multiply and solve to get x equals negative 30, d. And then number two, proportions are set equal. Solve, we cross multiply, and this time you get approximately negative 7.67, which is also d. And so, just wanted to cover that real quick before we get into a very important day, another one. I'm going to highlight this in bright orange, similar polygons. So today, we're going to be discussing similarity. That is a big, big concept for really the whole chapter. It's going to be focused on for really the whole chapter here. And we'll talk a little bit about what that is. But first, I want to give you guys a chance to do a little flashback here. Try our flashback here. This is like that dog problem we did on day one with the scale. So go ahead, guys, and see what you get for our flashback. And before you guys really get into it, just make sure you realize that the scale is centimeters and the actual height of the building is meters. So you're going to need to multiply this by 100 to figure out what that is. This is centimeters. So just wanted to point that out. But go ahead, guys. And so, guys, instead of having to do any cross multiplying, we just want to know what's the ratio. Well, the model is 16 as compared to 44,800, which is how many centimeters that building would be. But again, we always want to simplify. Try dividing 44,800 by 16. And I believe if you do that, you get 1 to 2,800. So for every 1 centimeter scale in this model, it scales up to 2,800 centimeters for the building. So that is a pretty big contrast there. But now, here's where we get into the meat and taters of this day, similarity. So this has two main concepts here. Similarity involves figures that have the same shape but not necessarily the same size. So it reminds me of a seagull. We use this symbol right here. It's like a little wavy. Sometimes you'll see me do it like that. In fact, I like this one better. Yep, it's like a seagull. How you used to do that when you were a kid, or how I still do them. So if you think similarity, think of another word that begins with S, not a four-letter word, but seagull. So in other words, we know this is a little different from congruent, which involves this symbol. So these are different. That and that are different. Now let's talk about how we know if we have similar polygons, similar figures. So big thing, they're similar if and only if their angles are congruent. So the angles are going to be congruent, but their sides are proportional. So their sides are not the same, but they're proportional. The ratios are equal, is what that's saying. The sides mean that if the sides proportions are equal, their ratios are equal, and the angles are the same, then you know you've got it. And this is where we bring back in scale factor, which is a ratio you get by comparing the lengths of corresponding sides. So this is going to go, scale factor is going to be involved with the sides. And so let's see how we do this. So a lot of times I like to use check marks to differentiate sides. I'll use check marks sometimes to differentiate sides. So for example, A, B, C, D is similar to W, X, Y, Z. And I want to remind you guys, order matters. Order absolutely matters here. So, for example, A to B corresponds W to X. So A to B looks like it's our longest side, so I'm going to put 4 check marks there, and it goes with W to X. Then from B to C compares to X to Y. So I'm going to put 3 check marks there. So these two sides are proportional. They're similar to each other. Then from C to D, 2 as compared to X to Y to Z. And then finally D back to A as compared to Z back to W. And so here's the thing. We're told A is congruent to W. So we're going to list the pairs of congruent angles and the extended proportion that relates to corresponding sides. So if A matches to W, then that's going to mean what matches to B? Well, that'll be X. What matches to C? That'll be Y. And then what matches to D? That will be Z. Okay. How about our sides here? So this is where we're going to do an extended proportion. If we know AB lines up with WX and BC lines up with XY, what are some other sides we could bring in here to verify this? Well, how about DC? Wouldn't it compare with ZY? And then how about AD? Wouldn't that compare with WZ? Okay. So I'm going to let you guys try number 2, please. See if you can match up our angles with these triangles and then match up the extended proportions here. Let's see how you guys did. Angle G matches up to angle K. Angle H, our 90-degree angle, matches up with our other 90-degree angle. And then our small angle here, one of our small angles, I, measures up with L. And then notice that this triangle goes at the top of each of these proportions. So GH, GI, HI. GI matches with the hypotenuse of this one, KL, or LK. And then HI matches up with LJ, Lamar Jackson. So guys, let's bring some algebra into this. We've talked, about the concept. Let's really bring in some math. So guys, anytime we're going to try to prove or determine whether a pair of figures is similar, we got 2 checklist criteria. 1, they need to have congruent angles. All their angles got to be the same. And 2, sides need to be proportional. So if you line up the sides and create a fraction or a ratio with them, they all need to reduce down to be the same value. So we look. Let's check our list here. So first, do we have congruent angles? 59, 35, which means that this third angle, we subtract both those from 180, that's going to be 86. Same 2 angles here, that's going to be 86. So yes, congruent angles. Check. Step 2, we need to prove that all sides are going to be proportional. So let's line them up. So it looks like A to B and D to E. So 6 over, that is 4, equals, line this one up over here. We got B to C, 9, as compared to E to F. So 9 over 6. And then finally, C to A is 10.5 over F to D is 7. And we need to reduce. We need to reduce these 3. So 6 over 4 reduces down to 3 over 2. 9 over 6 reduces down to 3 over 2. And 10.5 over 7, if you divide that out, it actually reduces down to 3 over 2. Hey, so yes. Do this so we don't get confused. Yes, we have similar figures. Hooray! These are similar. So now, with these trapezoids down here, I'm going to let you guys try number 2 for me. Nice voice crack. I'm going to let you guys see if you can check off our 2 things here on number 2. Go right ahead. So hey, we're off to a good start. All of our angles line up to be congruent. So that's a good start. Then I'll line them up. 40 goes over 24, 17.3 goes over 9.4, and 29 goes over 18. And when I divide these three, here's where the problem comes in. That gives me a proportion of 1.67, 1.84, and 1.61. And if even one of those doesn't line up, this is a no. These are not similar. Remember, our little Mignet or seagull means similar. No, not similar. So guys, the last similarity problem of the day. Man, this day's going by quick. Let's see if we can keep this up. We're going to write a similarity statement. So how would you guys fill in this blank? A to B to C to D is similar to, how would you line this up? That's right. We got L, M, N, P. L, M, N, P. Just like A, B, C, D. Because remember, you can follow the angles. 1 to 2 to 3 to 4. Now, we got to find the variable x. And here is where we're going to bring in a proportion. So if we're going to solve for x, and we know that 14 and 10 line up with x plus 6 and x, by the way, that's x plus 6 if you can't read it, then we know that's between 2 and 3. So 2 and 3. So we've got x plus 6 over, between 2 and 3, that'd be 10, equals x plus 9, which is between 1 and 2. Between 1 and 2 is 14. Now I'm going to let you guys solve this out for me, please. Okay, so we work this out, distribute, after cross multiplying, subtract the 10x over, subtract the 84 over, divide. I get x equals, hey, we're cool with the decimal. I'm going to turn that to 1.5, which is exactly what 6 over 4 is. So we've done that, we've done that. Now we got to find the measure of the indicated sides. So now that we know what x is, let's figure out what our two sides are. That'd be LM and MN. Let's take this, plug it back in, and we get, looks like LM is 10.5, and NM would be 6 plus 1.5, that'd be 7.5. Okay, so check that off. And then finally, we're going to determine the scale factor. So in order to determine the scale factor, we just need to line up. We just need to line up two sides that are similar. So in this case, we know LM is going to be congruent to 14, 1 and 2, 1 and 2. So we could do and I almost made a mistake here. We're going to go with this first shape. Since it's on the left, we like to go left and right. So I'm going to line up, let's go 14 scaled with between 1 and 2, that'd be 10.5. And let's see if that reduces at all. You can do 14 divided by 10.5. Turn that into math. Hey, that reduces down to 4 over 3. So our scale factor is 4 over 3. Remember, we always want to simplify. So again, that matched up with that. And so that is 4 and 3. All right, guys. Let's finish up with a couple of really good problems. This is a throwback. Remember us, I'm go different color here. Remember us talking two-way probability tables? And in my opinion, one of the most important things to do whenever you get a two-way table like this is first, figure out how many total people there are. So we got a total of 40 people in this survey. Also, figure out your categories. We've got grades, horizontal, and we have gender, vertical. You can see that right there. And so let's figure this out here. Remember, these are going to be, watch out for some conditional probability. And if we're dealing with conditional probability, that means we're only looking at parts of the population. So remember, with conditional probability, we're only looking at parts of the population. So for example, and we always know this based off the word given or assuming. So check it out. What is the probability that we randomly select a female? Here comes the kicker though. Given that slash they were a freshman. And that second thing, what we're given, knocks down the total population to only freshmen. So how many freshmen do we have? Well, we've only got 8 freshmen. And so now, out of these 8 freshmen, how many are female? Oh, going to be 5. I'm going to let you guys try number 2 for me. So check it out on number 2. Now we're saying, hey, we're flipping it. What's the chances that we select a freshman, given that we are only looking at females? I can relate. So they were assuming that they were a female. So our population is only going to be the 20 students that are females. And out of these 20 students, how many were freshmen? Looks like, boom, 5 out of 20. Or we got a 1/4 chance. So actually, you have a better chance of picking a female, given that you're only looking at freshmen, as compared to trying to pick out a freshman from all the females. All right. 2 problems left, guys. What's the probability? This is going to be different. This is actually not a conditional probability. What's the chances that we select an individual that is a female and a freshman? Okay. So female and freshman. We have an intersection here. We use a symbol here for intersection. And guess what? They don't give us a small population. We're looking at the total population. We don't have to narrow it down. So we're looking at all 40 people again. And we're trying to find out how many females and freshmen are there. Well, here's the female population. Here's the freshman population. You've got 8 freshmen and you've got 20 females. So we're going to have, but here's the thing, we only want freshmen that are females. So that would be where freshman and female intersects, boom, right there. That intersects at 5. Because they have to be both. They can't just be female or freshman, they have to be both. So that's 5 out of 40 or 1 out of 8. And number 4 is where it gets a little bit more complicated. Let's finish strong here, guys. What's the probability we randomly select the individual that is female or a freshman? So again, we're looking at the total pop. We're not narrowing it down as far as we're only looking at this group. So female or, we'll bust out the U, fresh. So this is where things get a little bit interesting. Our whole population is out of 40, but how many females do we have? Well, we've got 20. Or, we know whenever we're dealing with the word or, that's a plus. How many freshmen do we have? 8. But here's the problem. What do we have to subtract? So females, freshmen, you got to subtract the females that are freshmen. We're counting these 5 people twice. So we need to subtract out those 5 female freshmen that we're counting in both this group and this group. And so that ends up being 23 out of 40. So guys, our homework is going to be a really good practice multiple choice. There will be a Google form over this HDub. So Good luck and go Jumpers.